Hello everyone, this is video number 2. Before we go and use mathematical expression for linear functions, we still have, let's say, some preparations to do. First, let's talk about slope. Slope, if you remember from school, slope of linear functions are constant. Okay, let's give some example. Suppose you want to use ladder to clean your window of your second floor, but from the outside. Okay, let's try to draw the picture. Suppose this is our ground and this is your house. Suppose you have this is your first floor and second one, and this is your roof. And suppose you want to fix something at this point, and you want to take a ladder, and you place the ladder like this. Let's take another color, something like this. Okay. Usually ladder is a, if you look from this side, okay, you can see that the ladder usually is a straight line. Okay. Now this point attached to the ground, this point is attached to the wall of your house. Okay. Now what is the slope? Slope is actually an angle between the ladder and the ground. You can call it alpha, you can call it beta or theta, like this. Just a name for the angle. Okay, you can call it John if you want. Okay, just usually, okay, in mathematics you can call it as alpha or beta. Let's leave it as alpha. Okay, now if you look at any other point, let's say here, and you draw a parallel line parallel to the ground, this angle also is alpha. Okay, which actually every point that builds, let's say builds this ladder, okay, at any point you can draw parallel line, okay, to the ground, and any point you'll get the same result of angle, which means that the slope of this ladder is a constant. Okay, this is an example from real life for slope. Now you can I can also draw a picture of a not a constant slope. For example, if I write this equation, y equals x powered by 2. This function will look something like this. Okay, and as you can see, if you look at this point, okay, the slope will be something like this, and at this point the slope will be different, will be bigger. Okay, which means this function is not linear function because the slope is changing. Okay, because those first lectures that we're going to talk about only about linear functions. Okay. The second thing I want to talk about is the x-axis and y-axis. Now, how we draw y and x-axis. This is usually x, which is, you can imagine that x-axis is something like parallel to the ground, and y-axis is a perpendicular to x-axis. This crossover point is called origin of axis, okay, where x equals 0 and also y equals 0, okay. At this point, we won't talk about units of x and y like meters, kilometers. We'll just use them as numbers. The next thing we need to remember, just a second. Now from x0 towards this arrow, okay, all those numbers will be greater than 0. Okay, in this area of x would be all greater or equal to 0. And at this area, all numbers of x will be less or equal to 0. The same goes to y axis, which means at this area y will be greater or equal to 0, and in this area y will be less or equal to 0. You can also write something like this: in this area x greater than 0 and y greater than 0. In this area x less or equal to 0, y greater than 0 or equal. In this area x less than 0, y less than 0 or equal, and in this area x is greater than 0 and y less or equal to 0. Now, in first video, if you remember, we saw our first linear function, y equals 2 times of x, where 2 is actually was your magic or a function that you applied to independent group of x to create dependent group of y. Now actually the question, how can I or we, okay, draw this function on x and y system? So suppose we can take 3 points. For example, 1. X equals 1, therefore we have y equals 2 times 1, which is 2, which means we will have to find in this system this point where x equals 0 and y equals 2. Second point, x equals 2, therefore y equals 2 times 2 equals 4, and we will have to find this point where x equals 2 and y equals 4. The third point, x equals 3, therefore y equals 2 times 3 equals 6, and we will have to find the third point, x equals 3, y equals 6. Now how we can draw all these points and on a x and y system? This 1, 2, 3 is enough. I guess y won't be enough. We'll have to enlarge y-axis. Let's add some lengths. Y 1, 2, 3, 4, 5 and 6. Okay, let's talk about this first point where x equals 1 and y equals 2. Okay, x equals 1, y equals 2. Okay, if you look at the x-axis, x equals 1, we talk about this point. Now, what we'll do, you have to draw, okay, imaginary line that will go through this point x equals 1, and this line will be perpendicular to x-axis. Okay, the same goes to y equals 2, which is here. We will draw a perpendicular straight line that goes through this point y equals 2, and this crossover point, okay, this point where x equals 1, y equals 2. This called as a coordinate of this point. Now the second point where x equals 2, y equals 4. Let me copy this picture. However, I'll need to erase those points because we will build a second point. Now let's change the color maybe. Okay, x equals 2. We're talking about this point. So we'll draw imaginary line that will be perpendicular to x-axis, but will go through point 2. The same goes for y equals 4. And this point, crossover point, is actually a coordinate of this point where x equals 2 and y equals 4. Now you have your second point. Now we have to complete our third point where x equals 3, y equals 6. Okay, x equals 3 and y equals 6. 6 just here. And this crossover point, also called as coordinate, where x equals 3 and y equals 6. Okay, now I want to draw all those points in one XY system. Oops. First point was x equals 1 and y equals 2. Second point, x was 2 and y was 4. The third point was x equals 3 and y equals 6. Oops. Now you have 3 coordinates. Okay, and if you take more and more points, okay, you will see that you actually will have a linear function that will go through those 3 points. And this mathematical expression of this linear function or line, a straight line, y equals 2 times of x. And that's it. That's how you build your points of x and y and x in x and y system. I'm going to stop here, and the next video, okay, we'll try to build, let's say, a formula of a mathematical expression that will help us to build a function and of course to draw the function in x and y system. See you later.